Gravitation. As we all know that Sir Isaac Newton discovered gravitation, he kept the theory of universal law of gravitation in front of the world. But all this started in early 16s when the astronomer and mathematician Johannes Kepler introduced his laws of planetary motion. So, to understand how this idea of universal law of gravitation popped into Newton's mind, we must take a look on the Kepler's law of planetary motion. Kepler's law of planetary motion. In accordance to Kepler's first law, the orbit of each planet is an ellipse with the Sun at one focus. Now coming to Kepler's second law, the radius vector joining planet to Sun sweeps out equal areas during equal intervals of time. The last and the most important law is the cubes of the semi-major axis of the planetary orbits are proportional to the squares of the corresponding periods of revolution. Now let's come back to Newton. He used the second and third law of Kepler and deformulated the inverse square law of gravitation, which is that the force of gravity between two objects is inversely proportional to the square of distance between them. That is, F is directly proportional to 1 by d square. While there was a lot of pressure in Newton's head to prove the inverse square law, an incident happened with him, and after that he came up with the idea of universal law of gravitation and proved it to the world. Let's take a look on that incident. When the apple fell on Newton's head, then an idea popped in his head that two bodies attract each other and there must be something that attracts the bodies, and he named that something as gravity. Free fall. Whenever an object falls towards the earth, it is said to be in free fall. Newton proposed that all the planets are in free fall towards the Sun, just the same as the apple fell on his head to produce this insight was in free fall towards the Earth. The objects greatly differ in size, but the concept remains the same. Let us take a look on an experiment that Newton practiced to prove it. If a cannon fires a cannonball, it eventually hits the ground. If another cannonball is fired with greater force, it will go a little farther than the other ball before hitting the ground. If another cannonball is fired with incredibly immense force, it will produce a speed so that the ball will never hit the ground. Since it will fall at the same rate that the Earth's curvature is produced, it would thus always be falling towards the Earth, but will never hit it. Such an object would be said to be in orbit around the Earth. We know that no cannon can do that, so let's take a concrete example. All of the satellites and space stations that we have launched till now are in orbit around the Earth. They are brought up to an orbit in rockets. They are very far from the Earth and at such a great speed that they are always in a free fall towards the Earth but never touching it. This means that they are always in a fixed speed and radius. The same can be said for all the planets around. Newton concluded that any object with mass exerts gravitational force, but to feel the gravitational force, you have to go to something huge like a planet. Although it is correct that every object with the mass exerts gravity, the gravitational force is exerted by a car, refrigerator, and even by you, but the gravity exerted is just the negligible as compared to that of the Earth's. Universal law of gravitation. Now let's understand the components of universal law of gravitation. Consider two masses, m1 and m2, that are distance r apart, and a gravitational force of equal magnitude is applied on both of them. Now let's look on the math. Universal law of gravitation. According to this law, the force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Newton developed an equation to find the magnitude of the gravitational force between two objects where F is equal to the constant of universal gravitation g times the mass of the first object times the mass of the second object divided by the distance between them squared. Let's take an example for this. For examining a system like Earth and the Moon, we must understand that they both exert gravitational forces on each other, and these forces are equal in magnitude. Both of these bodies rotate in their combined center of mass. But don't forget F equals ma. So equal forces doesn't mean equal acceleration. If the masses are different, the Earth is 100 times as the mass of the Moon. Therefore, we see the Moon revolving around the Earth. The same is for Newton's apple. The apple accelerates towards the Earth and the Earth accelerates towards the apple. But the Earth is more massive than the apple, so the acceleration of the Earth is just negligible, while we can visualize the acceleration of the apple. Furthermore, we need to understand that the apple will fall on with the same acceleration that of bowling ball, regardless of mass, if we neglect the air resistance. Importance of universal law of gravitation. All the planets revolve around the sun due to gravitational force between the sun and the planets. The force required by a planet to move around the sun in a circular path is known as centripetal force. It is provided by the gravitational force of attraction between the planets and the sun. Tides in oceans are formed due to the gravitational force between the moon and the water. Gravitational force between a planet and its satellite decides whether a planet has a moon or not. Since the gravitational force of the planets like Venus and Mercury is very small, therefore these planets do not have a satellite or moon. Thanks for watching our video. We hope that you liked it and would learn a lot.